Hello viewers, welcome to JSM. In this session, I am going to explain oxy acids. Oxy acids. So now this is the important topic and frequently questions are asking in many different types of entrance examinations or competitive examinations. They are asking very frequent questions from this oxy acids. Oxy acids, and it is broadly classified into two types. Okay, so now this is a acid. It is broadly classified into two types. In that, the first one is what? Hydra acid. Okay, second one is what? Oxy acid. Second one is what? Oxy acid. So now hydra acid. Okay, so right, what is hydra acid? So now an acid which consists hydrogen only. An acid which consists hydrogen only, known as what? Hydra acid. For example, hydrogen fluoride, hydrogen chloride, hydrogen bromide. These are hydra acids. Hydra acids. So next one is oxy acid. Okay, na? An acid which contains along with hydrogen, if oxygen is present, that is known as what? Oxy acid. Oxy acid. For example, sulfuric acid, H2SO4, HNO3, nitric acid. So like this, along with hydrogen, if oxygen is present, so that is known as what? Oxy acid. Say for example, another is H3PO4 phosphoric acid and H3PO3 phosphorus acid. So all these are examples of what? Oxy acid. So now this is what? Hydra acid. In general, acids are in two forms. They are az form and ic form. So now ic form and az form. Ic form and az form. For example, ic form, if it is in any acid, central atom or central element having highest oxidation state with respect to group number, that is ic form, and it is less than highest oxidation state with respect to group number, that is known as what? Az form. So let us discuss with examples. So first I am taking third A group elements. So here third A group elements. Okay, third A group elements, right? It is third A group elements. Now third A group elements maximum oxidation state is 3. So first element is what? Boron, and by using this boron, here it is we are forming H3BO3. So now here it is the oxidation state of boron is +3. So now it is equal to highest oxidation state. So now its name is boric acid. Okay, so now here it is I am taking fourth A group elements. Maximum oxidation state is +4. So element is carbon. Here by using carbon we are writing carbonic acid, that is H2CO3. So now here oxidation state of carbon is +4. So now it is equals to highest oxidation state. So now name of this H2CO3 is carbonic acid. So like that, fifth A group elements maximum oxidation state is +5. So first element I am taking nitrogen. So here it is example is HNO3 nitric acid. So now in this oxidation state of nitrogen is +5, which is equals to maximum oxidation state. So now name of this HNO3 is nitric acid. So next sixth A group I am taking. Okay, so right, first element is oxygen, I am taking second element, what is that? Sulfur. So I am taking second element is what? Sulfur. Maximum oxidation state is plus 6. Plus 6. So now by using sulfur here, formation of acid is what? H2SO4. H2SO4, sulfuric acid. So now in this oxidation state of sulfur is equals to plus 6, which is equals to maximum oxidation state. So now it is said to be what? Ic form. Ic form. So now name of this H2SO4 is sulfuric acid. Sulfuric acid. Sulfuric acid. So like this, if any acid which contains central element oxidation state is equals to highest oxidation state with respect to group number, so that is known as what? Ic form of parent acid. Means what? That is ic form. If it is less than this, if it is for example 50 A group is there, highest oxidation number is plus 5. If it is less than 5, that form is known as what? As form. That form is known as what? As form. Say for example here 7th A group element also there. 7th A group element, so maximum oxidation state plus 7. So now here it is by using chlorine. By using chlorine, and sometimes plus 5 also possible. So that is for example here it is HClO3. HClO3. Here it is the oxidation state of chlorine is plus 5. Plus 5. So that is known as what? Chloric acid. What is that? Name of this compound is this acid is chloric acid. Chloric acid. Chloric acid. For example, HClO4 is there. Example here it is by using this chlorine here. Another example is what? HClO4. HClO4. So now here it is, its name is perchloric acid. Name is perchloric acid. Perchloric acid. Okay. So now what is the oxidation state of chlorine here? Oxidation state of chlorine is plus 7. If oxidation state of central element is less than group number, so that is known as what? As acids. For example, here HNO2 and H2SO3. H2SO3 oxidation state of nitrogen, here it is plus 3. So now here oxidation state is plus 4. Plus 4. So now name of this compound is acid is nitrous acid. Nitrous acid. And this is sulfurous acid. Sulfurous acid. So now this is the oxidation state which is less than group number. Here group number is 5. Oxidation state is less than group number. So it is what? As form. It is what? As form. So like that, sulfurous acid also same. Here it is maximum oxidation number is 6. Okay, here it is the oxidation number is 4. So now it is known as what? As acid, that is sulfurous acid. Sulfurous acid. So now these are the oxidation numbers are less when compared to group number. So they are known as what? As acids. In general, it is highly difficult to remember all forms of oxy acids. Oxy acids. So let us discuss how to remember all forms of oxy acids of an element very easily. Very easily. So now here it is in this diagram, this is the central box indicating what? Parent-ic acid. Parent-ic acid. So from this parent-ic acid, it is multiplied by 2 and followed by removal of one water molecule. Multiplied by 2 and followed by removal of one water molecule, we are getting a form that is that is pyroic acid. Pyroic acid. So now here it is what? This is the ic form, remember. So here it is ic form we are getting. What is that? From parent ic acid. Here it is multiplied by 2 and followed by removal of one water molecule. We are getting what? Pyroic acid. Pyroic acid. Okay. For pyroic acid, if addition of one oxygen, so now addition of one oxygen, we are getting peroxy diic acid. Peroxydiic acid. So here also we are getting ic acid, peroxydiic acid. So now from this parent ic acid, okay, so now here we are getting per ic acid, to this parent ic acid. If we add one oxygen, if we add one oxygen, we are getting peric acid. So now from this pyroic acid, removal of one oxygen, we are getting, okay, so now hypoic acid. So now here also it is ic acid. Here also it is ic acid, hypoic acid. Okay. So now from this parent ic acid, removal of one water molecule, we are getting metaic acid. So now it is also ic form, metaic acid. So now same, from this parent ic acid, if we removed one oxygen, we are getting what? Az acid. So now this is az form. This is what? Az form. Okay. So now from this az form, okay, so this is the az form is multiplied by 2 and followed by removal of one water molecule. So we are getting pyro az acid. So now here it is az form. It is what? Az form. Same, from this az acid, removal of one oxygen, we are getting hypoaz acid. So now this is az form. So now this is how to remember different types of oxy acid forms of an element. Remember one more thing. So right side maximum we are getting what? Ic form of acids, and left side we are getting az form of ic acid. So now this is the trick to remember different oxy acid forms of an element.